So while the room is still filling up, one first question. Who is still using Windows 3.1? Please raise your hand. No one. Who is still remembering Windows 3.1? Ah, those were the times, yeah. Okay, another question. Who is still using SQL 92? Uh-huh. So nobody is using Windows 3.1 anymore, but everybody's using, or at least some of you are using SQL 92. So that's the problem I'm going to talk about. Because actually nobody's using SQL 92 anymore. Because like Windows, it has been superseded by subsequent releases of the standard. And this is what I'm going to talk about today. About modern SQL, about more modern SQL than you might know. SQL 92 was not the last release. In fact, it's actually the first release that was kind of usable, I would say. The first widely used release. But other than that, it's not important nowadays anymore. So, welcome again. And this talk is centered about the SQL standard. There were many releases after SQL 92. I will go through them in chronological order and show you some of the interesting features that were introduced by these standards. I will also show you some use cases. I will compare how you can implement those use cases with more modern SQL as compared to SQL 92, which you probably everybody knows. So I'm going through standard by standard release. And the first release that came out after SQL 92 was SQL 99. And that was a real game changer. Because, believe it or not, starting from SQL 99, the SQL standard is not solely focused on the relational model anymore. With SQL 99, the guy said, okay, relational algebra is fine, relational model is fine, but for industry needs, we need also some non-relational stuff. And there it starts with the first feature I'm going to show you today, with the with clause. Who knows the with clause? Oh, quite some of you. Okay, the with clause is really fun. There's a trivial part of it, which I show you right now, and then there's the funky part of it, which is the with recursive, which I'll show you in a minute. So what is the with clause about? I will first show you a problem, which you might have seen in some SQL statements, if you get to see something like that, and you see that the very first time. How do you parse it mentally? How can you approach this query to understand what it's doing? So you're typically seeking the core of it, and then trying to make a sense out of that. And then you can make a sense out of the next level, from inside out. And you might find that there is another subquery on the same level. So let's first understand this one. And then finally, at the end, you might have an idea what this statement is about. I'm sorry, this is SQL because it's based on expressions. It's a declarative language. It's inside out. That's the way it is. But the with clause offers you another way to structure complex SQL statements. So with is indeed a new keyword. It follows a name of a statement scoped view, which I took A in this case. It's really just a statement scoped view. And you can also specify some names for the columns that view is returning. And then you provide a definition in the terms of a select statement, like a view definition. It's really very much like a view, just that it's not persisted into the database and not visible to other people, just to one statement. And there is the almighty comma, which means you can define another statement scoped view in the very same with clause. And the interesting part about this is that this can already see the previous defined statement scoped view. So you can refer upwards. You can of course go on. There's a third common table expression. CTE stands for common table expression. And you can do whatever you want to do in there. And there is now spot the gap, no comma. What does it mean? The main query is following now. So there is the main query, and this can access all the statement scoped views you have just defined. And the big difference is you can read it now in this direction instead of inside out. Maybe not a big deal for queries like that, but if they get hairy, it makes a big difference. So use cases for the with clause. Literate SQL, writing SQL that can be more easily understood and therefore more easily maintained. And there are some more obscure use cases which I just skim through. There are also the links. You can find the slides at the end then. So the with clause, think of it as private methods. Other programming languages have private methods too. Is anyone using Java in here? Yeah, okay. Is anyone using .NET in here? Oh, more than at the keynote, I think. So private methods, think of it. It is, you assign a name to a piece of code. Sometimes it's just for that reason, to have a name for a piece of code. That's a good reason enough for a statement scoped view already. But it's private, not like a view, so that everybody can use it. It's just valid for the select statement it precedes. So can you use that in your database now? Look at this. So who is using a database which is not listed on there? Raise your hand. Oh, at least a few. Which one? Oh, it is listed, but it's not working yet. Okay. So MySQL is a good point. You see that ping pong here? Just wait. It's coming. It's already available in the beta. You can download it and use it right now. It's just not GA. So it's in MySQL 8. The next release of MySQL will also have that. And all the other databases, including SQLite, can do that for quite some while. So is this now the most funky feature I've shown you today? No. Because now we go on to the next one, with recursive. Who knows that? Who is afraid of that? Ah, more. That makes sense. So what is it? Recursion. Oh my god, oh my god. The good news is it's just about syntax. There's nothing more than a loop inside running. I will show you the loop inside this in a moment. So how did we solve the problems, which we can now solve more beautifully with recursive? How did we solve them before? Not at all. This is one of the key features which make SQL Turing complete by now. And there was no other solution in relational algebra for that. So what is it about? Imagine a table which has, let's say, a hierarchy. You know that parent, parent, parent thing. Who has seen that before? Yeah, everybody has used that, okay? So what if we would like to select a subtree starting by one node? And we would also like to have the child nodes. How do we do that in SQL 92? The best but still worst solution is usually some kind of join. But that's getting ugly because it's only fetching one additional level of child. If I want to have two levels, I need another join. And of course, the way the joins work make this query now return 5 rows instead of maybe 7 like we would expect for each of the nodes. That's not what we're gonna get by these joins. Instead we have the data spread in the columns, which is really, really, really bad. So how does it look like now? Now there's a single query using this with recursive, which fetches all of these highlighted nodes. It starts, you see it at the beginning, at some ID, which I just put the question mark in there, and then it iterates through each level. To understand that, I will show you how it works with a simpler example, with a so-called row generator. Let's go through it. So it's still just a with clause, but I'm adding this magic recursive modifier, which allows some magic to happen. I have to tell the name of the column, so this row generator is just generating rows with one column called n. And the first part is executed first in this case. Select 1, so it gives me one row with one column having the number 1 in there. Great. So this is kind of sent up there, and then it appears wherever this statement scoped view is queried from. That means it's visible twice. The first time at the very end, at the main query, it immediately becomes part of the final result, because there's no where, no anything. But the more interesting part is inside that recursive CTE. Because now the second leg of this union is executed. It's running on this one row with one column having the value 1. It checks the where clause. Okay, 1 is less than 3, fine. It increments it by 1 because that's what in the select clause. And then it sends that 2 up there. And guess what? This 2 is now appearing down here, this next row. and there is a loop inside. You see it? That means you can actually use this recursive CTEs very much like a while loop in other programming languages. It's a little bit more ugly. Okay, I admit it's a lot more ugly, but still it gets the work done. So it goes through and through and through, and at some point this where clause says, okay, this doesn't match anymore. It removes that row and the machinery stops. If you forget this where clause, you will have a nice time. So how many rows can a database produce? A lot. So this is just one example, the simplest example to explain, but the use cases are more diverse. They are very diverse actually, because it's basically a loop. Although the name recursive just refers to the syntactic reference that the inside refers to itself. So can you use that in your database yet? Pretty much soon, so even MySQL users very soon, like 1 month or so, or maybe 2. Yeah. Who has used that before? Oh, a few. Who is scared of it? Still? Okay. Okay. Everybody using that for the first time will do something wrong. That's just normal. Okay. Next feature. Grouping sets. Completely unrelated. Who has ever heard of grouping sets? A few. So what is it about? One big limitation of SQL 92 is that you can only do one group by clause at a time. So if you want to have a report, for example, on monthly granulation, for each month, 1 row, 1 total, then you can do that, no problem. But if you would like to have at the same time the super total on a yearly basis, you can also do that, no problem. You can make another query, fine. And because SQL is so great, because it was invented by scientists, I mean, that must be great. It is composable. You can even combine these queries into a single one. Okay, you just put a union all in there. You just make sure, sorry, that was one too much. Just put in a union there. You just have to make sure the columns are the same name, same number, same type, and that's it. You have one query that delivers you both of it. And in reporting, this is a surprisingly common requirement. Therefore, there's a more simple solution now. So in the group by clause, you can now have the so-called grouping sets. And there you can say, hey, I would like to aggregate the same data twice. Once on yearly and monthly, which basically means monthly basis, and once again on just yearly basis. And it does the very same thing like on the left-hand side. It's just less typing and more fast in execution.
How does it know to throw away the month?
Because it's written there in the brackets. So the first one, if you look at the grouping sets, then the first line, it says year, month. That's the first grouping. So it does that. And then it does it again on just the next one. You can even put in an empty set of brackets there to group by over everything. Okay? Silence. Okay. So what is it? It's really just multiple group bys in one run. You just put what you would write into the group by clause, you just put into another set of brackets, put it into a grouping sets clause. You can use the empty brackets to group by over all rows if you really would like to. There are some shortcuts. So there's a function to disambiguate the meaning of null. Okay, not so important. And there's some shortcuts like roll up and cube. Who has ever heard of roll up and cube? Interestingly, they are more commonly used than the plain grouping sets, but they are just shortcuts to like this here. Yeah.
Assumption that the month column is nullable.
Yes.
There are also null values in there.
Yes.
There are typically 2 rows with the year and null, or would it be combined to 1 row?
It depends whether. So per default, it has union all semantics, so it's not combining anything. But in theory, but no database supports that, you could write group by distinct, then they would be removed. This is something which the standard has, but no database does, because who needs that? So nothing is combined if you use just group by. That's the simple answer. And the other answer, maybe which you did not ask, if there's null in the data actually in there, there's this grouping function which I mentioned there. And this one can be used to ask is this column now part of the grouping key or not? And there you get a number back, and you can check whether it is null because the data happened to be null or because the grouping was done on some other thing. Welcome. So can you use it yet? A little bit. A little bit. MariaDB and MySQL, they have the roll-up mechanism. So if you say roll up by ABC, then you will get ABC, AB, A, and nothing. And then you can still filter what you don't need, which is in most cases still faster than a union. So a little bit at least. So these were just 3 selected features out of SQL 99. I'm now skipping to SQL 2003 because I have to limited time, you know. The first feature that's completely underestimated, but yet so important in so many cases, or at least convenient in many cases. Filter. Who has ever heard the keyword filter in SQL? Always the same. Have you seen this talk before? Okay. So just one thing ahead. In SQL, most aggregate functions drop null values before doing their aggregation. That's something which I will need in a moment. Pivot table. Who knows a pivot table? What is that? Yeah, from Excel. You know, everybody's using Excel. Raise your hand if you're using Excel. Okay. So what is it about? If you have a long report, which let's say on monthly granulation, like we just had it, and you would like to turn it into something wider, where you have one column for each month, but just one row for each year. How to do that in SQL? It's simple, actually. So I'm here grouping by year. When I'm grouping by year, it means I'm getting one row per year. As simple as that. And then there is the funky part. I'm building the total, so I'm using the sum aggregate function. And inside the aggregate function, I'm using a case expression. I'm checking, is this value belonging to the month I'm interested in, first month, January? If so, I take it. Otherwise, I just take 0 to not change the result of that. Yeah, funky. That's indeed one way to do pivot here. You can make it even shorter if you use that null value, because in the case expression, if you skip the else clause, else null is implied, and null is not used by aggregate functions, as I just mentioned. So if you do that 12 times, you will have the table as desired. And this is now the new feature, because case is already old. Every database can do the case, that's fine. You can still use that solution, it's not wrong. It's even fast, it's fine. But this one is more easy to understand. After each aggregate function, you can have a filter clause. There you have the where clause again. And the aggregate function will just get that rows which match the where clause. This additional where clause. So you do this one 12 times and you are done. In one picture, always think of the simple part first. If you want to get one row per year, just use group by year, then you will get one row per year. And then for each column, you just pick the values using the filter clause, which you would like to get. And now comes the good part, or actually the ugly part. Can you use that? Who's using Postgres? You can. There is even a plugin from MySQL, but that's an ugly plugin, but it works. It's using a regular expression on the SQL string. It scares me, but it works. But you can still use the case approach. Okay, the case approach is still valid. It's just more syntax and less obvious what it does. Now coming to the really funky parts. The really great window functions. Who knows window functions? Who loves them? There's a saying, there was SQL before window functions and there is SQL after window functions. Let's look at them. So the keyword over is where it all comes together. And what's the problem it's gonna solve? SQL 92, it combines two distinct concepts in a way which turned out to be not the ultimate answer to everything. These two concepts are merging rows, combining rows that share some common properties. And the other concept is aggregations, condensing several rows into a single row. I will show you in a matrix. So you can either do neither of those two. You can just select data, then you're not combining any rows and you're not doing any aggregations. But then you can use the distinct keyword to do a deduplication. which kind of merges rows which happen to have the same value in all columns. Besides that, you can also use the group by clause, where you can specify the key values which shall be compared, and those which have the same values in those columns will be condensed into a single row. And on top of that, you can then use aggregate functions. Okay, but watch the gap. How to do some aggregations without doing group by? And that's not possible in SQL 92. Actually it is, because SQL is composable. Watch it out. So we just start with the plain query, because I don't want to do a group by on that. Hey, I can do a subquery here. I can join this lower query in there, and then I have both at the same time. I have the original data, and I have the aggregated data. And I can finally access this column in here. Okay, that's perfectly fine, because SQL 92 solves all of our problems by composability. Who has to say something bad about composability? Me. I can see it in your faces. Yes, it works. We could do that. But is it fun? No. So there's a different solution now. These are the so-called window functions. And the basic idea is, if you want to use an aggregate function without using group by, you have to have some other means how you can specify over which row you would like to use that aggregate function. And that's the keyword over. Over which rows would you like to use that aggregate functions? I show it to you step by step. Imagine a query, imagine its result. And the first thing is the most important, but it's hard to spot. Right next to the salary column, watch the magic, it's the comma, the almighty comma. So important in SQL, I'm sorry. So what's next? If you want to use an aggregate function, just use it. And then, if you don't want to put a group by clause there, just use over instead. And I have used the simplest yet valid over clause possible, the empty over clause. What does it mean? It means over the entire result which we have constructed so far. In this particular case, it means it hits all of these rows. It will add a new column, because I started with the almighty comma, it's a new column. And then I have there the sum over of all 6 rows I have in there. That's it. Of course, we can tailor this a little bit. So we can use in there the partition by keyword, which segregates the rows very much like group by does. So if you have a key in there, like the department column, it will segregate the rows which have the same value in those columns. That means there are 3 groups, then it's called partition, but basically groups. And the aggregation is just built on the rows belonging to each of the groups. But that was just the first part of the over clause. The next part is order by and framing. I will show you again an example. It's the running balance, like imagine banking or whatever. You put in some money, you take out some money. What's your current balance as of transaction X? Like, this is what I would like to get, another column, balance, and I would like to have the sum in there. Whatever I put in or put out, it shall just be calculated like this. How can we do this in good old SQL 92? Of course, we can use composability. We can just put a nested query in there, which just considers all the rows which happened before this transaction. That's perfectly fine. It works. But I don't like it anymore, at least. Nowadays, this is another example where I would like to do some aggregation, but we don't want to use the group by clause. So how to do that? The problem is I would actually like to use the over clause instead, but there is this less than or equal sign in there. And this is something which we have not yet learned how to put that into an over clause. So this is the topic now. Instead of a subquery, we just use the aggregate function and we use the over clause to specify over which rows we would like to make this aggregation. And then we have the order by clause. which does not change the result of sum, like 1 plus 2 is still the same like 2 plus 1. But we specify an order for the sole purpose to reason to the database about which rows we would like to aggregate. Because now, once specified an order, I can say, hey, I would like to make a so-called frame which reaches from unbounded preceding according to this order by clause until current row where I'm just working at the moment. And when this query is run, at the first row it will just aggregate the first row. At the second, the first two, and so on, and so on. So this allows me to reason about this aggregation window in terms relative to the current row I'm processing. Now I see, oops, I forgot something, because there's one more column account. I didn't take this into consideration, which means I have now put your money into his balance. That's maybe not the best idea. So we need to consider this account as well. But this is very much like group by and so on. So we can just put the partition by clause up there. It combines well. You can use partition by and order by, no problem. And now the result will be right again. So once you have established an order in such a overclause, you can also use other functions like row number, range, dense rank, and things like that. Once you have established an order, you can use that order to narrow the number of rows you would like to aggregate, but you can also use it for some special purpose functions. So in a nutshell, what's the main use case of this overclause? Aggregates without group by is still the most common use case for the overclause. Other than that, you can do running totals, like I've just shown you. Moving averages, you can say between 3 preceding and 3 following. That's fine, works. Ranking, of course, all these functions I've shown you before, dense rank, rank, row number, and so on. Top n per group. I would like to get the 3 most interesting posts for each category, for each topic. You can also use the over function for that. Avoiding self-joins. If you're nowadays using self-joins, you are doing it wrong. Self-joins are really a thing of SQL 92. Stop it. If you see a self-join, always one of the tools how you can avoid it. And many, many more. So, the overclause may follow any aggregate function which you know. All the ones like count, sum, min, max, and so on, and also the more fancy ones like the standard deviation and all of this. It basically defines which rows are aggregated at each row. So it can have a different set of rows at each row. That's quite interesting. Empty overclause marks everything. You can use partition by and also order by and the between clause to say which rows to aggregate. Can you use it yet? In most of the database you can already use it. In MySQL very soon. And in SQLite maybe never, who knows. However, window functions. There was SQL before window functions and there's SQL today. And once no SQL databases start to implement features from SQL, then it really means something. There's more than one kind of no SQL or new SQL or whatever database that also implemented this concept in some way. And they're getting more and more and more. Window function is really, if there's only one feature you're remembering from this talk, make it this one. Or this one. Inverse distribution functions, just a very short thing. Just to show you the most scary statement I have in this presentation. The median, the middle value of an ordered set. Okay, how to do that in SQL 92? And there you see composability as its best. The upper part is doing nothing more than numbering the rows. But if you don't have a function like row number, then you have to revert to ugly stuff like that. And the lower part just picks the middle one. So that's the median, the middle value. Okay. If you look carefully, it's accessing the same table 3 times. Did I say something bad about self-joins yet? Yeah, if you see a self-join, kill it. Yeah. Okay, so that's a scientific answer, but yeah, no practical answer. So, and this is the query today. Select percentile disk 0.5, which means it's the median because the range goes from 0 to 1. And then you say within group order by, and then you put the value you would like to use to order by on, and this is also the value you get in return from this function. But there are two different versions of this function. The one for discrete values and the other one for continuous values. And if you imagine 4 rows, which, let's say for simplicity, have the values 1 to 4, and you would like to see how these functions work, the argument of the function has the range 0 to 1. And if we use this percentile disk, it splits it up into 4 different ranges. And if you say 0.5, then it hits the second one, so you get the result of the second row in that case. If you use percentile continuous, then it means something different. It is a linear interpolation between the closest values you have. So if I take 0.5, I also hit it in between those two values, between the second and the third. And then it does a linear interpolation into those values, so something in the middle here. Can you use that yet? Not so much. But surprise, surprise, MariaDB, the next MariaDB. Who is using MariaDB in here? Oh, at least. So the next one, 10.3, will have that to some extent. Not the full support, but to some extent. However, if you need median or 95 percentiles and so on, very useful. So, skipping to the next SQL standard. There was one which I skipped entirely in 2006. It's just because I don't like that very much. There was XML in there. Who likes XML? You see. Okay, so in 2008, we got an awesome feature. Everybody has used it without knowing it, because it has a different name in the database you're using. The fetch first clause. What is it about? Ever heard of limit? Who has heard of limit? Ah, okay, you see it. Limit is not standard. Okay, limit is therefore ages. It limits the number of rows you get. So if you say limit 10, you just get 10 rows. However, it was not standard, and then they standardized it, and they used some more keywords for whatever reason. Another way to do that, this is also perfectly valid SQL 2003, because it uses the over clause with the row number, so it's numbering the rows, and then it cuts off the unwanted ones. That's also perfectly valid, but a lot of typing, so let's just take limit. Or fetch first 10 rows only. So this is now the SQL standard way to using limit. Otherwise, it's pretty much the same. Can you use that yet? Yeah, a little bit. So some databases have actually implemented all these keywords, others not. The yellow one means just there is limit, which is equally easy to use. And yeah, just go ahead if you like. However, I need to talk about limit because interestingly, 3 years later with SQL 2011, they added another keyword. Who can guess it? No? Offset. Who knows offset? There's a teaser. There are coasters down here. They're free to take. And there is this no offset logo on there. It's there for a reason. There are also stickers. They have printed a URL where you can read about why offset is the worst idea of SQL ever. Okay? Just noting right now. Feel free to take the stickers afterwards. So what is it about? It's about, if the usual use case is pagination. Show me the first 10 results, then the next 10, the next 10, the next 10. But what people are forgetting that in between fetching the first and the next results, there might be some change in the system, like new rows coming in. And if you then say offset 10, it means to skip 10 rows, throw them away, and if it's renumbered again, so if something changed because new data came in, then you don't get the logically following rows. So that's therefore a pretty bad idea. Besides that, it's also slow. So it's wrong and slow, which is pretty great. Therefore is this no offset campaign of me started. So you can take the stickers and the coasters, and there's a URL. You see this URL. There you can read about the details, and most importantly, how to live without offset. It's not like just telling you offset is bad and not offering any solution. There is a solution. Read about it. It's a talk of its own. So many photos. Thank you. Tweet them. Question. No simple solution. There could be a simple solution, but then, going into details and details and details. But we can have a chat afterwards if you like. Okay, so can you use offset in your SQL database yet? Yes, you can. It's in fact the only slide where all bars are green in this presentation. You just shouldn't because it's ill-designed. Take the coasters, trust me. Next one, over. In SQL 2011 there was another extension of the over clause. And I will demonstrate it again by showing you how it is done without the over clause first, and then showing you for comparison how to do it nowadays. Again, imagine a query and its result. And all I'm doing in the first step is I'm numbering the rows using the other over clause, row number over some order. So now I have a row number column there. Now I'm defining this as a statement scoped view using the with clause. We have already seen that. So all I'm doing is I'm giving this a name, numbered t, and this I can use in the main query now. And I can do, of course, a self-join. Why I'm doing this? So I'm putting this result twice next to each other, but if you look into the on clause, I just push them apart one level, so that I have the current and the previous one next to each other, so I can take the difference of them. And all what I'm doing here is the opposite of the running total which I've done before. For the running total I have just accumulated transactions up to this point, and here I'm just doing the difference. What's the difference between this row and the previous row? It's pretty much the opposite of it. So it demonstrates how you can use the with clause if you want to use the same statement scoped view twice, but using something twice means you're doing a self-join, which is pretty much always wrong nowadays. So with SQL 2011 we got such simple functions like lead and lag and ends value and first value and last value. So the query nowadays looks like this. Take everything, balance, subtract the previous value, which is lag, according to the order I'm specifying in the over clause. And that's it. Just take the previous value according to this order. And there we have the difference. So there's lead and lag. You can, with lead, pretty much look into the future, into the next row. There's first value, last value, out of the partition or whatever you have defined your frame from. And ends value. You can ignore nulls, respect nulls, and all of that. Can you use it yet? Yes, in quite some databases. Pretty much all of them. Soon, at least. And that's really extremely handy. Next feature, also SQL 2011. System versioning, who knows that? Oh, at least one. Which database are you using? Ah, you win. SQL Server has system versioning since 2016 release. So I will show you to something. What's the problem? So if you do in SQL, if you do some data modifying statement, insert, delete, update, or merge, I don't have merge in here, but merge is also HTML, it's kind of destructive. It kind of overwrites the data. There's no regular way using SQL to gain access to this old data again. Of course, you can recover backup, but that's not a regular way to access old data. And nowadays, we have system versioning and application versioning. I'm just demonstrating here system versioning. So if you create a table, it might have columns. And you might want to, or you just add one more column, or two columns, which specify at which point in time, during which period, that row was valid. So you have one row, one column that says when it was born, this version of the row, which is generated always as row start, so that the database automatically puts the timestamp in there when you make a new row version. And you have, of course, also the end time. And then you combine these columns logically into one period called system time, because this is about system versioning, which means this period from start to end, this is the period when each of the rows was valid. And at the end you say with system versioning. And bam, if you insert data into that, the database will automatically put in the start timestamp there, because also the end timestamp, because they are generated always as. If you update, it's not that the old data is gone. It's just updated, the temporal validity is updated. So the end timestamp of the original data is set, and the new row will have the according beginning timestamp. the same thing, if you delete something, it's not gone. It's still there. It's just marked invalid by setting the timestamp properly. However, all of that is transparent when you do the changes, insert, update, delete, but also when you do the queries, select. You don't see the data. If you run a query select star from this table after deleting something, you won't see it again, unless you ask for it explicitly with new SQL syntax. Following the table name, you can now say, for system time as of that point in time, and then you will get the response, how did the content of the table look at that time. Fully automatic. Okay, so at least one can use that yet, SQL Server user. How about the others? It's a pretty recent feature, we must admit. Okay, so the commercial databases all have that to some extent, some more, some less. But look at the balls up there, the indication. MariaDB is already working on that. In 10.3, you can already download it and try these examples, and they work. I just did it last week. They work there already. So a feature like this is coming to at least one open source database in the near future. Let's see how the others do with that. Do you like that feature? Oh, okay. It's coming. Okay, finally, reaching the current standard. 2016 was the last release of a SQL standard. And there's another of these features. There is SQL before this feature and SQL after this feature. It's called Match Recognize. It's awesome. I will just skim through it because I don't have the time anymore, but it's really awesome. The bad thing, it's a recent edition and only available in one of the commercial databases yet. Oracle, yeah, you said it. I like it anyways very much. So what is it about? Let's look at a log file as an example. And you would like to have there some hits, like think of a web log. So there are some hits. And you would like to group them according to the rule whenever there is a gap of more than 30 minutes, then let's consider it a new session. And I would like to do a grouping by session, so that we have the sessions in here, and that we can do some statistics with them, like min, max, and so on. So this is the query. Okay, yeah, that looks ugly. What is it about? And in good old tradition of SQL, it makes more sense to read this part, which is in this match recognize brackets, from down upwards. Follow me. I'm defining a variable called cont in here. And this is a variable for a condition, which pretty much reads like it belongs to the previous hit if it falls within 30 minutes. That's it. Then a row qualifies as a continuation of an existing session. And now comes the funky part, the pattern clause. This is actually something like a regular expression. I'm trying to matching rows, not characters. In regular expressions we are matching characters, but here we are matching rows. And new stands for any row. Any row is matched. So it will match the very first row for this new thing. And then it will try to match rows against this pattern I have defined there in the next row. So it will try to see, is the next row, does it fulfill this condition? So does it fall within 30 minutes? If yes, it matches it. And then it will try to match it again, because I have the star there. And this is the star you know from regular expressions. Match it 0, 1, or many times. I could have written a plus there, which would mean match it once or many times. Regular expressions. Who knows regular expressions? Okay. It's basically regular expressions, just not on characters, but on rows. Then you can actually do something like group by at the same time. You can say all these matches I would like to have combined into a single row, one row per match. You can still access all of those rows like first and last and do some calculation with them. And yeah, that's pretty much it. So first and last, which is then the duration, And here I'm calculating the average duration just for demonstration. If you try to do that with window functions, it looks like this. I will just skip through because time is running out. So this is the overclass. You can nest it until indefinitely. So yeah, this is how it's done without this new fancy thing. If you're interested in that, I have another set of slides for just this feature. Have a look at that. So can you use it yet? Maybe in the near future or not. Who knows? Who knows? So that's it. I have shown you some selected features out of many, many standards. There are more interesting features, which I did not have the time today to show you. So like lateral, Boolean, and nulls, nulls first, nulls last, like order by a nullable column, how to do that. There are many, many more interesting features. You can find them in the slides on my website. Today I had to skip them because time is limited. So before we come to the questions, one more word about who the fuck is this guy down there. My name is Markus Winand. I'm doing training for developers, mostly on SQL performance indexing and modern SQL, you guess it. The interesting part is that I run a website called usetheindexlook.com. Who knows that? Ah, wipes. You know the cutest squirrel on the planet? It's the index JDI index squirrel. This website has actually been turned into a book, which you can also buy if you like. What's the difference between those two? The one is for free, the other one pays my bills. And now I'm doing pretty much the same, so I'm starting a new website called Modern SQL, you guess it. And there I'm already writing about all these new features and many, many more. And this might eventually become a book as well in the distant future, who knows. But this is my current project that I'm working on. You are welcome to look at the website, subscribe to the free newsletter and all of that. And of course, you must come down and grab the no offset coaster or sticker and learn about how to avoid that. Other than that, I'm done. I'm ready for a few questions, if you have some. Otherwise, I will come up. Yes, there's one. Yes, it is. You can find my presentation on this URL. Okay, that's the only one that people are interested in. Questions? Otherwise, I will come up with questions, and they are... there's one. Yeah, so do I have experience with storing JSON in like Postgres? With SQL 2016, the latest release, JSON support was added to the SQL standard. But if you know right, that like pretty much every database has had JSON support before that, which means every database is doing it differently. But at the time being, if you think about Postgres, I think in 11 there will be more standard conformant JSON support, which just means more functions to use. Other than that, the standard implemented it quite differently than in Postgres. In Postgres, there is a distinct type for JSON, like JSONB and so on. The standard doesn't have a distinct type for JSON. It just uses CLOPs or whatever, and then has functions to parse them and to morph them and all of that. And do I have experience with that? Yes. I mean, I use it sometimes. Use it when it's okay. I mean, if you have a more specific question, I can try it. Yes. Yes, absolutely. I was scared, but it worked. Of course, I mean, what it is used for is most of the time if you receive some JSON from some external party to just store it. That's what it is most of the time used for, because you don't have the control over the data scheme delivered by some external vendor. So this is the case which I have seen most often. It's nothing bad about it. You can put indexes on it, you can put constraints on it, you can make sure that every JSON has some key if you like to, but you don't have to. Yes? Is UUID support part of the standard? I don't know, I must admit, but I don't think so. But I don't know. I would need to check it specifically for that. Does anyone know? Does anyone ever have seen the standard itself? All the 4,000 pages? Okay. I don't think so, because I think I would have seen it. but I didn't see. But I would also have to grab basically through it to tell you the answer. Okay, so one more. So how does it influence developers, especially when they are working with some ORM tool like Hibernate? If they are working with such tools, it should not limit them. There is one saying by Gavin King, the creator of Hibernate. Let's stick to that. And he said, just because you're using Hibernate doesn't mean you have to use it for everything. And the interesting part is that you can misunderstand this quote, because some developers understand it like, oh, in project X I'm using Hibernate and in project Y I'm not. But that's not what he meant. What he meant is that for one particular process which you are implementing right now, Hibernate might make sense, and for the next, in the very same application, it might not make sense. So when does Hibernate make sense? What it was done for is for this cycle where you load a complex object graph, then run some business logic that affects many of these entities, and then writes back the changes. So if you have this cycle, like loading, modifying, writing back, this is what Hibernate was made for. But if you don't have this cycle, you might not want to use it for this specific use case. For example, if you're just querying data and not modifying them and not writing them back, using Hibernate might be the wrong choice for this particular code base, or for this particular class or whatever function you're just in there. In that case, a plain old query might be good enough. And if you stick to that, then I think it should not limit developers, because when it makes sense to use this function, it might just be a case where Hibernate is anyway not the right tool. The problem is that many people are using Hibernate binary, like either use Hibernate not at all in a project or for everything in a project. And this is wrong. If you're using this, then you are indeed very, very limited. But that's not a fault of SQL. It's not that SQL did not solve the problems we have. There are solutions to many, many of these obstacles we love from the relational algebra. There are no more convenient solutions nowadays. It's just we have to use them. And if the tooling is not allowing you to use it, then you should reconsider the tooling. Yes. I'm running over time, but I think the next one is the break anyway. Is that right? Okay, go on.
Sometimes completely different syntax, and that's the reason why Hibernate will often be used.
Yeah, so another aspect of Hibernate which you're bringing up is that it improves the portability. Let's put it that way, because there are different dialects and it can emulate some features and some specifics. Yes, that's true. That I cannot argue against. It's a valid point. So if this is really the most important thing to you, okay, go for it. There is, if you even use plain SQL, I mean, there is a standard, and many vendors are following it, at least in the important aspects. It's sometimes tricky, I must admit, to write SQL that works on many, many databases. Especially I want to say that if you're testing, this is now just because you said it, if you're using a different database to test your code against, yeah. Okay. Yeah, even then, I mean, you will just get it later on, the difference, because especially H2, I mean, I know this, it's fast and so on. I'm not a fan of this approach, to be honest. But yes, then you limit your development to the subset which is offered by both databases, which you are supporting, also for testing, developing. If you want to test during development using H2, then you have to limit yourself to the features which also work with H2. Okay. Okay, so I'm still here. Come down, grab the coasters, grab the stickers, and ask me for anything. I'm still here the whole day and probably tomorrow as well. So thank you.